All right, today we're proving whether two events are independent. Now, you know the basics behind independent events, where one does not affect the other. But what about empirical probability? Well, there's two ways that we can do that. We can prove it with this formula. So if two things are independent, then we know that A probability of A given B, remember those are the words, is equal to the probability of the first one, or A in this case. Remember, these are the first one. Or we can say that the probability of the intersection, remember A and B, is equal to the individual probabilities, multiplied together. So just to use these formula to get an idea, we can prove things are independent here. So if they're independent, we know that the probability of A and B is equal to the probability of A times the probability of B. So I'm doing that because this is the one they gave me. They gave me the and, so that's why I'm going to use this one. That's 3 out of 20. Probability of A is 3 out of 5, and B is 1 out of 4. So if I do the math, remember this is a proof, so we just do the math on this side. We don't cross over. That's 3 out of 20. So we don't know if this is true, but those match, so this is independent. Okay, next one. So here we're using and, but they're using the word instead, but remember, that's that. So simply remember, when you're proving, you should state what rule you're going to prove first. So make sure you show this always when you're doing a proof. So this is 3 out of 50. Is that equal to 3 out of 10 times 1 out of 4? So 3 out of 50 is equal to 3 out of 40. No, that's not. So they're not independent, or they're dependent. Okay. So this one here uses the conditional here. So we know that that would mean that probability of A given B is equal to the probability of A. So this is kind of extraneous information. You don't really need that. So is 1/5 equal to 1/2? No, not independent. Or you can just say dependent. Either way, it's all good. Okay, final example. This is the probability of A given B, is that equal to the probability of A? Remember, it's always the first one. So again, that's extra information. So 9 out of 20 is equal to 9 out of 20. So this is independent. So you can see kind of what they look like. Now you can also use these, if you know that these events are independent, you can use these properties for your own benefit. So I know that they're independent, so I know that those two rules, the probability of A and B, I don't know what happened, some crazy stuff, is equal to the probability of A times B. Like, you can use this information to solve them. So they're telling you the probability of A and B. So this is the one that I can use, is probability of A times the probability of B. So probability of A and B is 11 over 80. Probability of A is 1 over 4. But I don't know what the probability of B is. I'll just divide. These cancel out, and I find out that the probability of B is 11 out of 20. So same basic idea here. You could try this one, that'd be good. So the probability of A and B should be equal to this. So again, I'm trying to show you that you should always write this out when you're doing a problem like this. So divide by 13 over 20. And the probability of B is 3 over 5. This one's even easier, because when you're using the conditional, probability of B given A, that's literally just equal to the probability of B. So extra information here. So 3 out of 10 is probability of A. So that is the probability of B. When they're independent, it doesn't matter if it rained or if it didn't, kind of thing. So again, probability of A given B. Oh, excuse me. Should be equal to the first one, the probability of the first one. So probability of A given B is 11 out of 20. So the probability of A is 11 out of 20. Fantastic. So now we have Venn diagrams. Just take a second and fill out that Venn diagram, if you can. Okay, with a problem like this, remember when you have a probability, the probability of the whole thing is 1. So this box represents 1, or 100%. So they tell you that the probability that a student has hearing loss, or a teenager has hearing loss, is 0.15. The probability, that they listen to loud music. This is loud music. It's 0.15. And the probability that they have hearing loss is 0.4. Okay. We can draw a Venn diagram, and that's what they ask you to do here. But the next thing that they tell you is do not listen to loud music. Probability that they do not listen to loud music or have hearing loss. That means that they don't have either. So that's outside. So what you have to think of is it's all out of 1. So this or, these two added together is 1 minus 5, 1. So it's 0.49. But when I add these together, the 0.4 and the 0.15, I get 0.55. So I subtract that from here. This is how I get the 0.06 where they overlap. Okay, the easiest one to do here would be probability of A and B is the probability of A times the probability of B. So we have to try and prove that. So probability of A and B, remember that's the overlap. It's equal to the probability of A, which was 0.15, the original, not the just, times the probability of B, or L and H, whatever. So 0.06 equals 0.06. That works. So these are independent. Okay, so are these independent? Now, which formula should you use? Well, this one has given in it, so I'm going to use the probability of the givens. So probability of baseball, given it rains, is equal to the probability that he plays baseball. So probability he plays baseball is 0.45. The probability that he plays baseball, given that it rains, is 9 over 20. So I had to disguise this. So 0.45 equals 0.45. So these are independent. Whatever, I spelled it wrong. Okay, finally here we have a table. And I want you to prove it in 2 ways. The first way, prove that a basset hound and being male are independent events. So basset hound, given that you're male, should be equal to the probability that you're a basset hound. And the second way would be probability that you're a basset hound and male should be equal to the probability that you're a basset hound times the probability that you're a male. So we're just using the formulas in different ways just to determine. So probability that he's a basset hound given that he's male. Remember the formula. So basset hound and male is 10 over male, which is 24. Is that equal to possibility that he's a basset hound, which is 22 out of 44. Are those equal? No. This is like 5 over 12, and this is like a half. So no, so these are not independent or dependent, whichever you choose to write. The other one is you do basset hound and male. So basset hound and male is 10. Remember, this is not conditional, so it's always over the 44. Probability that he's a basset hound, that's 22 out of 44. Probability that he's a male is 24 out of 44. So when I reduce these, I get 5 out of 22 equals 3 out of 11. These are not the same, so same idea. Have a good day.